Nice to meet you again. So this week I took a walk from where I live to this Battersea Power Station behind me. It's really nice place here, and to see everywhere is being decorated for Christmas now. A lot of people as well. Um, so this week we're gonna talk about the business of the life cycle. And that is a very important topic for uh, business objects, and hope you like it. See you.
Hello, hi everyone. Welcome back to the new session. So today we are going to talk about a very important topic in business object for the life cycle. So we will go through four different topics. So we look at the overview and then go into the state within the life cycle and look at what property or algorithm we can specify. Uh, then we look at the monitor rules, which is quite interesting area in life cycle because that's where the batch actually kicks in, and a few of the scenarios need to be implemented as monitor algorithms. Um, and number four, we look at event of sequence, and it is quite interesting and it's quite difficult to understand for a lot of people. So, but I think it is really beneficial if you understand what are the events happening at the background, especially in the case of life cycle. So let's move on. So first part for life cycle overview. All right. So first of all, BO can have life cycles, and different BO can have different life cycles. And what I want to emphasize here is life cycle can be defined um, based on business requirement. But there are some patterns where we always see, for example, the first state, uh, people normally use a pending state with a batch uh, used for the monitor process. So this kind of design is to allow the system to process large amount of records, especially for this type in a batch job, and it can make sure the system is able to handle the volume. And there are other considerations when we look at things like how we can raise a to-do and automatically close the to-do once the condition has been resolved. Um, the other things will be for a monitor algorithm, we would define it and wait for a particular condition to be met and then move on. So there are patterns we can use. There are techniques we will need to learn, and hopefully we will be able to discuss those ones at the end of this session. The second one is the life cycle state. Okay, so obviously life cycle is made of a list of states, and on each of the states you can define the rules based on the requirements. And then we have transition rules between the state, which state can transition to the next states. They can be defined within the life cycle. They can also be defined, for example, on a particular condition, I want to move to one state, vice versa, another condition to other state, for example. And the last one is the state options. State options provides a few benefits. For example, if I want to make sure in certain state the record can be edited, then I can add the option say it can be it's editable. But there are other things. For example, you can use it to indicate what is the conditions or multiple conditions from the last state to enter this state. So the options is really a additional flag you can add for this for the property of this state besides the algorithm you define. All right, so second part we talk about the state. So on the lifecycle states, you can define three types of system events. One is enter, one is exit, one is monitor. And enter and exit is simple because when you enter a state or exit state, these algorithm will be triggered. Monitor is something we need to look at that a bit more details in the next chapter. Normally, monitor is triggered when the enter algorithm is executed, and if you don't have a monitor process defined on the state, the monitor algorithm will be triggered straight away. Otherwise, if you have a monitor state process defined, when the batch is running, which is the monitor process, the monitor algorithm will be triggered. So there is a concept of periodic monitoring or deferred monitoring. We'll look at that a bit later. Okay, so this is a bit of as I have done that in the last few videos as well. I like to look at things in a more data representation way, because very often if you want to query certain information, you do need to go to the database, which might be easier for you if you know where exactly you want to go. So over here we have a business object, then we can define state based on the business object. For each of the states, we could define transition rules. We can define the state option, and most importantly, we can define algorithms based on different system events, enter, exit, or monitor. Again, we look at this similar concept on the algorithm type, and potentially using a plugin script. During the last session, when we look at the business object rules, so that part of the concept is the same. It would just be a algorithm plugged into the state rather than the BO itself. Number 3 is the monitor rules. Okay, let's look at what the monitor rules can do. And I'm just giving some examples here. So first, it can check the condition periodically. So for example, if you have a requirement to say, I need to wait for a particular date before I can move on. So what you can do is you can create a monitor algorithm and say, for this particular date, if it reached, I will go to next condition. Otherwise, I'll just stay. So every time the batch is running, it will just execute this logic at the back end and decide whether it should move on or not. Second one is the conditional transition. So if you, let's say, if you are evaluating a condition, say if this process has been completed, if you're checking against another process, if it's true, you will actually um, move on to a state as well. If it's false, you might just keep waiting. Or you can say if it's false, you go to a different state, and if you don't know what state the other process is, you just keep waiting. So you can add multiple condition rules, and within the algorithm, you can decide whether which action or what next status this particular build need to do. And next one is the wait and timeout lifecycle. So very often we have requirement to wait for a particular evaluation to happen, and if it's similarly to let's say we are waiting for another process to happen, but what happens if it's just never happens? A lot of the cases you would define a timeout condition. You say based on let's say for the 2 days after entering this particular state, nothing has happened. Then I would think the message is lost. Then we'll just probably move to a final state, say cannot continue. And to do might be raised on the next state as an enter algorithm. So a lot of the design pattern could be utilizing the monitor rule to make business decisions in terms of the business, in terms of the life cycle transition in the case. Okay, so here I want to emphasize one concept here. So we have two types of monitoring. And you can see this actually on the not on the BO, but also from the monitor. From the MO maintenance object. So if you look carefully, for example, if you're looking at let's say market message maintenance object. If you go to the maintenance object and look at the options that's been defined, you will see a periodic monitoring algorithm, I would say. So that will be an algorithm, it will be a periodic monitoring batch. Okay, so that batch, if it's running, it will basically check any state which have a monitor algorithm and then run it. Okay, so it is running in a sequence of the state sequence, but it is not limited to any monitor process on the state. So that means if you don't define monitor process on the state, periodic monitoring is able to pick up the monitor algorithm and run it. And this is quite often used when you don't have dependency between objects and between, let's say and it is not dependent on the dependency because you don't have to run monitor algorithm in a particular sequence. Okay, and the benefit of this is actually you can say I don't have to specify which batch job I need to run. There's just one batch job. As long as I find a business object on a state where there is a monitor algorithm, that one will be triggered. It's easier for the system to schedule in your batch scheduler. And comparing with the other option, which is called deferred monitoring. Now, deferred monitoring is basically saying I have a particular state in the life cycle. I would define a monitor process. Very often you will see that monitor process called deferred batch. Um, and what happens is these kind of deferred monitoring algorithm needs to be run in a particular sequence. For example, if you have say a market message, you might have an algorithm on the error state for uh, reprocessing, and you might have a algorithm on validation. So in that case, you would need to validate the market message when the monitoring the battery is running. Okay, so in both cases, you can define them as different defer market message. Sorry, defer different batch control. And in the batch scheduler, you can say, I want the batch control on the arrow state to run first. Because normally what that does is I want to retry it and move that into validation status. And then you will run the batch job on the validation status, because in that case you don't actually miss out this particular run. You will say all the error ones and the new ones will be validated together. Obviously, I mean, if it's still error out, you might decide to go back into the error queue, or the new ones go into the error. But that gives you a chance to make sure the error ones is validated within this batch run. Sometimes you don't run the batch, at real time. You might schedule that for every 4 hours. If you have missed this particular run, it would wait for the next 4 hours, which is quite a long delay for some of the critical cases. Okay, so deferred monitoring is more about precise sequence of running logics, and the 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 bad thing about that is you have to be very explicit on the batch scheduler. You have to, if you use deferred monitoring very often, then you have to tell the batch scheduler which batch to run and in what sequence. And there is obviously there will be a dependency between these batch runs. Okay, so last one is the event sequence. Okay, so this looks a bit complex, but I want to go through this with you because I think if you understand what is happening in this case, you will actually understand why sometimes the ordering of the rules will be happening when you try to debug. And sometimes the rules need to be altered or change system events if you want the particular rule to run at a particular point. Okay, so it's quite simple. Okay, I take one example here, which is a business object and a maintenance object. We can define rules on both business object and maintenance object. And I want to let you know what is the sequence of these rules being run at different objects at different system events. So the first thing will be running when you try to calling a BO or running an algorithm on the business object is it will run the pre-processing rule for the business object. Okay? And then the second thing it does, it's something hidden in the maintenance object. It will need to look at what is the current status of the maintenance object. And probably that's make you feel a bit because you never seen these things happening. But you have to think about why the BO status code is always a mandatory field. And this is actually one of the reasons because the status actually decides where it is in the life cycle. And from there, we will know what algorithm on the life cycle need to be run afterwards. So status is very important in this sequence. And number three is just the MO processing based on the rules over there. And number four is determine BO. So on actually most of the maintenance objects, you will see there is an algorithm defined called determine BO. Basically what it does is it takes the MO and it takes the ID of this object and decides what BO it is. Because the same MO could have multiple BOs. Okay? And then what happens is at this point, I know what BO it is. What is the business object from the maintenance object? And we can run the validation rules on the business object. So remember we have business object rules and we have business status rules. So far, we have run pre-processing rule on the business object, and then we run the validation rule on the business object. It hasn't reached the status rule yet. Now, the next is basically the state transition rule. So there are a couple of rules about moving states. For example, I'm not going to expand that too much, but basically it's saying do I actually move the current object to the next status, or do I actually change the status? But normally what happens is if I change status, I trigger enter algorithm. First I trigger the exit algorithm of my previous state. If I move into a new status, I trigger the enter rule for the new state. And potentially I'm running the monitoring rule as well in the case of periodic monitoring. And if this is the end of status transition, I move back to the BO level. The post processing rule on the BO will be run, and the last event will be the audit rule. So this is a sequence of events potentially is happening when you are triggering a BO with Lifecycle. Okay, I think it's very, I'll say it's very technical, but it is very important to know what is the events happening at backend, especially when you're trying to debug your code. Okay, so before we finish the session today, I tried to think about two patterns we use quite often, and it's probably two user cases we're using almost every project. So the first one is inbound, let's say inbound marketing message. It could be anything, could be an inbound read, um, anything loaded from external system, but need to be processed in a large volume. And what happens is normally you will see a pending status with a monitor algorithm, a monitor process and not monitor algorithm for delayed processing, which means the batch will be running and take all the pending records on this BO and then process them in threads. And very often when it's start processing, we run through some validation. If the validation fails, it moves to a waiting for resolution status. On entering the status, there will be a enter algorithm to raise a to-do. So user get notified, the to-do points to the particular records for the business user to make a decision, and they'll resolve it, and probably after that we'll rerun the validation until completion. One thing I've seen is a lot of people put a monitor algorithm onto your waiting for resolution, and that is against the purpose of waiting for resolution state. Because if you put a monitor algorithm there, that means automatically it's just going to get raised, but you only have a very short window until the next batch run, and then when the next batch run, you just do the exit. So it ends up with a lot of creation of to-do and closing the to-do, where the business user may not get the chance to review the problem yet. So some common mistake I have seen that in that sense. Another one, I would say this is a customer case, could be any customer case raised to the business. Business would like to resolve it based on some automatic rules, or it could be a menu process to resolve. If the resolution requires a customer response, maybe an outbound message gets sent, checking the system will be checking periodically on the customer response status with a monitor algorithm. Once that is fully resolved, the user could be closing the case, and basically from the resolve state, the user say, I want to close, move to case close status. A status transition UI map could be defined on the case closed state, where basically a pop will be showing, and the user is able to enter a reason for it, for auditing, for reporting purpose. So this is another example where we would use the lifecycle very often in this way. Okay, so that's everything for this week. Thank you very much, and see you next week.